Hi, I'm an old guy and I do maths, and today we're trying to figure out how we calculate the radius of this circle given the information we have. We have a bisector of a chord which measures 12, and this bisector, which is perpendicular to the chord, has a length of 4. So let's put that information into the circle below this and go to work. Okay, so first things first, this is a bisector. This is 12, so that and that are the same length. That is 4, therefore that is 6. Now hopefully that makes sense. Right, so a radius. Well, that runs from the center of the circle out to the edge of the circle, any point on the edge of the circle. And that's a property that we're going to utilize. So there's a radius. Also, we can draw a radius down from here to here. Now, it wouldn't really matter if this was skewed this way or this way. Our radii would still reach out to the from the middle of the circle to the edge of the circle. Given that this was a bisector of the chord, all we'd have to do is line it up and we would still have a radius that ran down through this bisector to the center of the circle and over to a point such as this or such as this. Okay, so what do we know? Well, as I said, we know that this is 6 and we know that that's the radius. What we need is this measurement in here, and that is r minus 3. No, it is r minus 4. What am I saying? It is the radius minus this 4 units here. Okay, now let's just extract this and draw what we've got. A little bit of freehand drawing here. We know that that is r minus 4. We know that that is 6, and we know that that is r. We also know that that is a right angle because it is opposite this angle here, and we have two straight lines. There are other reasons as well, but that's a good one, so we'll go with that one. Okay, so what do we know? Well, we know that 6 squared plus r minus 4 squared is going to equal r squared. I think we are in business. So let's expand this and get some results. So 36 plus r squared minus 8r plus 16 equals r squared. Now, this is a perfect square, and the reason that I was so easily able to expand it is because it's a perfect square. The rule says that I square this, r squared, I square this, 16, and I multiply this negative 4 by 2 to get negative 8, and times it by that. If that's somehow mysterious, have a look at my videos on the expansion of perfect squares and the difference of two squares and all of those. It's sitting in the quadratics playlist, and it's well worth a look if this is mysterious. Now, some tidying up. Okay, well, r squared minus 8r plus 16 plus 36 is plus 52 equals r squared. Okay, I hope that makes sense. I hope I've got everything there. Yes, I have. Now, we can get rid of these. cancel. If we move this one over here, it becomes negative. Add that to that, it becomes 0. So we can write this as negative 8r plus 52 equals 0. Right, well, if we move the 8r, the negative 8r rather, so 52 equals 8r, if we move this from here to here, we do so by adding 8r to that side and 8r to that side. So we get 52 equals 8r. And r, therefore, is equal to 52 over 8. Now, 8 goes into 52, 6 8s are 48. 4 remainder, 4 over 8. So that gives us 6.5. The radius is 6.5. 6.5 we'll put there. Okay, now, is there some means of checking this? Yes, there is. So, let's take our triangle again. I'll just stand it up this way. We know that that is 6. We know that that is 6.5, or we think it is. Now, if this is 6.5, r minus 4 is going to equal 2.5. So, we'll just check this using a bit of Pythagoras, and let's see what we get. So 6.5 squared minus 6 squared should equal that squared. What do we get? We get 6.5 squared minus 6 squared equals 6.25. We find the square root of that and we get 2.5. There we are. There's the working in there on the calculator. Hopefully you can see that. X is equal to 2.5. Well, that's a tick. That's a tick. And that's a tick. 6.5. And that is how this problem is solved. Thank you very much for watching. I hope you found that useful. If you did, please like and subscribe, and I'll see you next time. Bye.